In this video, we are going to see what is the Viviani theorem, how we can prove it, and how we can use it. Based on the Viviani theorem, the sum of the distances for any interior point, let's say P, to the sides of an equilateral triangle is equal to the height of that triangle. So in this case, if I call this triangle A, B, C, and if we agree that this is an equilateral triangle, then I can choose any interior point here, let's say for example here, and if I call it P, then the distance of this point to the sides of this triangle, so if I call it S, U, and T here, so the sum of these three distances should be equal to the height of this triangle. Let's say the height here is H. So I can write S plus U plus T is equal to H. Before we start to go to the proof, let's take a look at another equilateral triangle here and see what is the properties of an equilateral triangle. For the equilateral triangle, we know that all the sides are equal and all the angles are equal, which means each of these angles will be 60 degrees. Another point here for the equilateral triangle is that the area of this equilateral triangle, let's say S, the area of triangle ABC, this should be equal to radical 3 over 4 times S square of the side. So if I call this side A, and A. Another point for the equilateral triangle is that the height of this equilateral triangle, let me call it H, of the triangle ABC, will be equal to radical 3 over 2 times the side. And this is very easy to prove. You just need to draw the height here and then use the Pythagorean theorem, and easily you can prove these two equations here. So now let's go back to the Viviani's theorem here. So to prove the Viviani's theorem, I'm gonna divide the triangle ABC to the three triangles using point P. So if I connect these, P to B, and then P to C, and then point P to A, you see I have three triangles. I'm gonna color them here just to make them more visible. So this is one of the triangles. The other one is this guy here. And the last one will be this guy here. So if I call this triangle 1 and call this triangle 2 and call this triangle 3. As you can see, we can easily write that the area of the triangle ABC, so I'm gonna call it S, of the triangle ABC should be equal to the area of triangle number 1 plus the area of triangle number 2 plus the area of triangle number 3, right? So now I'm going to write these areas. Because the triangle ABC is an equilateral triangle, I know that the area of the equilateral triangle will be radical 3 over 4 times a square, the square of the side. So if we call it a, I'm gonna write it here, radical 3 over 4 times a2. This should be equal to the area of the triangle number 1, which is this triangle here, APC. So the area of that triangle will be 1 over 2 times the side, which is A, times the height, which is T, plus the area of triangle number 2 here will be again the side, which is A, times the height, which is S, times 1 over 2, plus the area of triangle number 3 again will be 1 over 2 times A times U. So if I write this equation here again, I will have radical 3 over 4 a2 is equal to at over 2 plus as over 2 plus au over 2. And if I cancel out the a from both sides, I'll have, and also multiply both sides by 2, I'll have t plus s plus u is equal to radical 3 over 2 times a. And we know that also radical 3 over 2 times a is basically equal to the height of the equilateral triangle. So this was the way that you can prove the Viviani's theorem. So now let's take a look at this problem here. The problem says the triangle ABC is an equilateral triangle, and the area of this triangle is equal to 16 times radical 3. And now we want to know what is the h1 plus h2 plus h3. If you look here, the h1, h2, and h3 are basically the distances of point P, which is an arbitrary interior point for triangle ABC, to the sides. And this is the explanation of the Viviani's theorem. Even if you do not want to use the Viviani's theorem or you don't remember it, you can easily, the way that we prove the Viviani's theorem, divide this triangle to the 3 triangle and then write the area of the triangle ABC based on that 3 triangle, and then find the final answer for this problem. Here, first, I know that the area of the triangle ABC is 16 radical 3, and also I know that this triangle is an equilateral triangle, and the area of the equilateral triangle is radical 3 over 4 times side square, which now it should be equal to 16 radical 3. And if you solve this, you will see that a is equal to 8, right? And again, based on Viviani's theorem, I can write h1 plus h2 plus h3 should be equal to the height of this triangle, which is radical 3 over 2 times a. If you remember that, why? Because ABC is an equilateral triangle, and this guy, if I use a equal to 8, will be 4 radical 3. If you like the video, it would be great if you like it and also subscribe the channel for more content. That's it for today, and peace.